Car tires need to be inflated properly. Overinflation or underinflation can cause premature tread wear. The data and scatter plot below show tire life for different inflation values for a certain type of tire. We're going to find the quadratic polynomial that best fits this data and graph the polynomial together with a scatter plot. We're also going to use that polynomial to predict the pressure that gives the longest tire wear for that particular tire. So pulling up the graphing calculator, go Stat 1 for edit, and we're going to enter in L1 26, down arrow 28, 31, 35, 38, 42, and 45. Then use the right arrow to go over to L2 and enter 50,000. And this data is the expected life of the tire, down arrow, 64,000. Miles, 80,000. 81,000. 72,000. 71,000. And 59,000. Just checking the data. I think we're good. All right. So first of all, let's draw the scatter plot. Let's go second stat plot. And we notice that plot 1 in my case is already on. If it's not on, then press 1 and then select on. Then we're going to go to the window and we're going to set the X min at 15, the X max at 50, the Y min at 30,000, and the Y max at 85,000. Now we can press graph, and there is the data. Expressed as a scatter plot. So now let's get the equation of the quadratic polynomial that best models this data. So we will go back to Stat, over to Calc, press 5 for quadratic regression, second 1 for L1, comma, second 2 for L2, press enter. And this time we are to round our data to 3 decimal positions. And so our A is negative 275.062. Our B is 19,745.685. And our C is negative 274,059.354. So those are the coefficients in the quadratic equation, or quadratic function in this case. So I'll go back in, and so we've got negative 275.062 x squared, where the x is the pressure in pounds per inches squared, plus 19,745.685 x minus 274,059.354. Then going back to the graphing calculator, in order to draw, we're going to go back to y equals, and beside y1, we're going to enter ax squared plus bx plus c, and we're going to get the a, b, and c that were stored from the quadratic regression equation in vars. So we press var, 5 for statistics, 2 to the right to the equation, 2 for a, and then a appears, and then we go to our x and squared, plus var 5, 2 right arrows for EQ for equation, 3 for B, X, plus C. So var 5, 2 right arrows, and C is 4. And now when we press graph, we see not only the scatter plot, but also a graph of the polynomial. And I'm sorry, we were given to use the y min of 250, and so let me 50,000 or 25,000. So let me just fix that, because I used 30,000. So 25, 1, 2, 3, and back to graph. Now part C asks to estimate the longest tire life based on pressure. And we're to round that to 2 decimal places. The units will be pounds per inches squared. And so we are to find the maximum of this function and where it occurs. So we go second calc, 4 for maximum. Our cursor is close to the vertex, so I'm going to press enter. Move over to the right of the vertex. Press enter again. Press enter one more time to let the calculator make the guess. And the maximum of 80,307 miles for Treadwear occurs at 35.89 pounds per inch squared. 35.89.